Unit 5 is going to involve several types of problems that involve quadratics. So we just want to refresh your memories on how the quadratic formula works and when to use it, how to use it, and to be as efficient with it as possible. So first off, recall that we are using the quadratic formula when an equation is not factorable. So if it's factorable, you definitely want to use that first since it's faster. But if you can't, then we want to resort to this formula. The formula is listed there for you, and that should be committed to memory for sure. But notice that there's a plus and minus symbol in that formula. That means that you will have two answers to these in most cases. For the example that's listed here for you, 4x squared plus 4x equals 7, we have to make sure that the quadratic is set equal to 0 first. So the first thing I've done on the right side for my steps is to subtract 7 to the left. Then we write the quadratic formula out. Now that step is something that is useful to you if you feel like it's easier to plug things in if you write it every time. If you're able to insert the parts without writing it out, I'm okay with that as well, but that's a possible step for you. We do need to identify what A, B, and C are. I find it helpful to write them down so that you don't make a mistake with a sign. I have inserted a step 3a here to calculate the discriminant to determine the number of solutions. That does two things for us. The first thing it does is it allows us to know whether we're going to have any answers to the problem, and we can stop right there if we get a negative result, because that's the number that's going under the square root. But the second thing it does for us is it allows us to plug fewer numbers into the square root, and it just makes things a little bit more streamlined. So for this one, if I solve b squared minus 4ac, I did that off to the right in the margin, came out to 128. That tells me that there's two answers to this problem. And so I'll insert that 128 into the square root and use that to solve. So the final thing after I've substituted those values is to simplify it. If it tells us to use simplest radical form, we'll do that. But if it doesn't, then most of the time we're going to want a decimal version of it. So on the calculator, I'm typing -4 plus square root 128, hitting enter, and then dividing by 8. You just want to do that whole numerator at once. And then I go back and do it again, -4 minus root 128, and divide it by 8 again. So those are my two answers. We'll use it in two decimal format. So that would be the approximate value of that equation. All right, so just some more examples of this. Working on the left side of this, solve for x using the quadratic formula. If you want to pause at this point and try these, that might be a good idea. And then you can come back and see how you did. So I've identified A, B, and C in number 1 because everything was equal to 0 already. And I did the discriminant next. 7 squared minus 4 times A times C came out to a positive number, so I used it and got my two answers. For number 2, I needed to rearrange it so that the 10 came over to the left side. I needed it to equal 0. Identified A, B, and C, calculated the discriminant, came out to positive 76, so I was good to go. Insert that into the formula and solve it. So there's two solutions to that one as well. All right, on page 2, more about the discriminant. If the discriminant is positive, there's two solutions. The reason is the plus and minus will apply to whatever that square root is. If the discriminant is 0, though, then there's only one solution, because if you do the square root of 0, you get 0. So adding and subtracting 0 does not give us two different answers. So there's only going to be one in that case. And if the discriminant is negative, there are no solutions because, again, we cannot take a square root of a negative number using real numbers. All right, so when the directions say to determine the number of solutions, really all we are interested in is a discriminant. Again, you must have the equation equal 0 before you can calculate that. But after that's been rearranged, we just pull the coefficients out, insert it into the discriminant, and decide. So number 1 came out to 0, number 2 came out to 2 solutions, and number 3 came out to 1 solution. Okay, and so that's it for page 2. If we go on to page 4, page 3 is going to be some practice for you. Page 4 is where we're getting into the exact format. So sometimes an exact answer is needed when we're solving a quadratic, and that means you have to give an answer that is not rounded. So in order to give an exact answer, we must simplify the radical and leave it as a simplified radical. So example 1, I've done the same procedure. I've gotten the discriminant first, came out to 12. I insert that into the quadratic formula along with the A and the B, A and the C. And so as we can see with x equals 8 plus and minus root 12 rather, over 2. That root 12 simplifies into 4 times 3. And so that square root of 4 becomes 2. And now I have 8 plus and minus 2 root 3 over 2. The last step to simplifying this kind of fraction is to simplify both halves. So I'm taking the 8 over 2 first and writing that down as 4. And then the 2 root 3 over 2 would reduce the plain 2's and give me root 3, 1 root 3. All right, so we want to insert the discriminant as usual, but then if we can simplify it, we do. Example 2, I had to move the 1 over. Once I did that, discriminant came out to be 48. 48 simplifies to 16 times 3, so it's 4 root 3. And again, I divide the 6 by the 6, get 1. Divide the 4 by the 6, get 2/3. And I'm always going to put the root in the numerator if it's part of a fraction. And so 1 plus and minus 2 root 3 over 3 is my simplified version. All right, if you want to take a minute to try the classwork problems here, these are actually notes for you to take. So if you would write those down and try them, and then you can check your work. All right, and as you see with number 1, 6 plus and minus root 7 is our final result because it does reduce at the end. For number 2, if b equals 0, that means that there's not going to be a number at the beginning of the numerator when you do the formula. So plus and minus root 180 turns into plus and minus 6 root 5. The 6 is reduced. Now I still have 2 answers because my discriminant was positive. They're just opposites of each other, plus and minus root 5, because there was nothing to add or subtract before it. And then number 3, again, it reduces 10 over 2 equals 5, 2 over 2 equals 1. Right. So it just depends on whether you're told to do it in exact form or not. If it's exact form, you just need to simplify the root. If it's not, then you can go ahead and get a decimal answer.